One way to create a compound element is to right-click on the white space in the viewport and select Create Compound Element. This will add an empty compound element to add elements into. However, in the ring modulator file, the circuit for the ring modulator is already set up, and we can group the existing elements into a single compound element. First, delete the connections from the ONA and the DC source. To ensure that the ONA result data is not carried into the compound, we'll remove the circle around the port that was previously connected to the ONA input. To do so, go to the Mouse Mode toolbar and click on the Monitor Ports button. Then click on the circle. Now let's go back to using the Select cursor. Now, click and drag in the viewport to select the elements to group together. Right-click and choose Create Compound Element. The selected elements are now inside this compound element. Select the compound element, right-click, and select the Edit option. The Property Editor tab lists all the properties of the compound, and the default properties are inherited from the root element. In the Ports tab, I can add 5 ports by clicking the Add button 5 times. The data for 4 of the ports should be optical signal, and the 5th should be electrical signal for the modulation signal. All port types are set to be bidirectional. I can set the location of where the ports will appear on the element icon. Click on the Arrange button, which sets the location of each port in order to have even spacing between the ports. The Results and Scripts tabs allow us to define custom result variables and to use scripts to set up the internal elements. Click OK to accept the settings. I can now connect the ports to the ONA and DC source. Next, select the compound element and right-click to select the Expand option to open a new viewport tab that shows the elements in the compound and the relays that correspond to the ports of the compound element. Connect the relays to the circuit. At this point, we can run the simulation and see the same gain result as before we created the compound element. If we were customizing the model to represent a Foundry component, we could load modulation data from the Foundry. In the optical modulator standard properties, I can set Load from File to True, and select a data file containing the measured data, which could contain the real and imaginary parts of the effective index, or absorption and phase as a function of the modulation voltage. To show the parameterization capability of the compound element, I'll edit the compound again and add a property called Radius, which will be used to set the lengths of the straight waveguide elements that make up the ring. Set the kind to distance, which will allow me to set the length units for this property. Set the value to 40 for a length of 40 microns. I can select the Annotate option so the value of the property will show up in the schematic. Under the Scripts tab, I can add a setup script to set the length of the straight waveguides as a function of radius. An alternative way of doing this would be to use the expression option to set the length as a function of radius. We will set the length of the modulator using the expression 0.8 times 2 pi times radius, where radius is between two percentage signs to show that it's being inherited from a parent, which is in this case the compound element. It can access the value for the radius parameter that we've just added. Click on the Test button to check to see if there are any errors within the setup script. The script output shows that the script completes with no errors. Click OK. I can now change the radius of the compound element in the Property View window and the lengths of the waveguides inside the compound will automatically be updated. Lumerical University's Scripting 100 course and the introductory scripting tutorials in the link below this video are good resources for learning more about scripting.